name is Carl. Welcome to my YouTube channel, but not to my workshop. Today we're out and about and we are at the East Fortune Aircraft Museum. So we're going to have a look round and see what we can find. First thing we found, is, just as you've driven up, is this BAC 111, British Aircraft Corporation 111. Much beloved of British Airways. These were designed in the early 1960s as a short-haul airliner. This one was built in 1968 and it had its last flight for British Airways in 1993. And then we went to the RAF Museum at Cosford, which is where I did some of my training at Cosford Defence College of Aerospace Technology. And this aircraft was moved here in 2006. And it's been here ever since, as Harry's just telling me now.
Yeah.
So we'll go over to the bulk of the museum now and have a look round, and hopefully we can get inside this one and have a look, and we'll show you that later on. So come on then, Harry, let's go over to the main part of the museum. So this is where we are. As you can see, it's the so-called National Museum of Flight Scotland, and you can probably tell from that picture what they've got here. And this is the site of the former RAF East Fortune that was a Royal Air Force station during World War II. And prior to that, in World War I, it was a Royal Naval Air Station. And it was a standard bomber airfield with 3 runways in an A formation. So we'll get inside now and go and have a look.
Supersonic passenger plane because the Russians' Tu-144 exploded in mid-air and the Americans failed to build theirs.
So we're going to have a background noise, but here is a really good view of the ogive wing shape of the Concorde, which gives it its supersonic flight characteristics. Here we can see the intakes of the 2 Rolls-Royce or Bristol Siddeley Olympus engines. And this is what gives it the so-called Super Cruise facility. So basically these flaps here can move up and down, and they can slow the air down, the supersonic air that's entering the intakes, so that when it meets the face of the compressor, it doesn't stall the compressor. And they work in conjunction with these flaps here. So by moving those flaps and opening and closing these ones, airflow can be directed into the compressor in such a way that even though the aircraft's flying at Mach 2, the air that meets the face of the compressor is suitable for the blades to then take it and compress it, put it into the combustion chamber and then into the turbine. Here's one of the main undercarriage legs, and these are probably, I don't know exactly for sure, but I would say this is probably maraging steel that they're made out of. Up there, look, you can see where it attaches to the fuselage. Retraction leg there, or retraction ram rather. And the locking mechanism. Brake fans on these as well. So the brake unit is in here. Inside the wheel is the brake unit, and then we have brake fans to try and keep the brake temperature down. Can you imagine trying to stop this thing, even with thrust reverse? Must take some real doing. So we've got brake fans to keep the brakes cool and stop them basically bursting into flames. The tail end, or the business end of the Olympus engine, so this will be all stainless steel and titanium because it gets very hot. And if we move round to the back, this is where the afterburner would be. And here you can see, as we rotate round, here are the clamshell buckets, thrust reversers basically. So I'll show you one of these in close-up in a display in a minute. So you can see there that they hinge, and by moving together they then direct the thrust of the engine forwards to slow the aircraft down. And I suspect there's no engine fitted to this aircraft, but that's where the afterburner would be, and I'll show you one of those in a really good view looking along the length of the fuselage. And if we walk forward, you can really see the wingspan here now. And as we move forward, we've got some equipment hatches here. So that one says hydraulic servicing, so that's probably where they would have connected the hydraulic ground charge cart. And there's access to hydraulics, so that must be the hydraulic bay in there, where most of the hydraulic components, at least for the power side, would be located in one area, so you could easily access them to do any fault finding or repairs. Moving along, ground conditioning connection here. So you plug your conditioning truck in there to keep the aircraft cool when it was on the ground and the engines weren't running. A water drain there for the fuel system, so I'm suspecting this is a tank running along the bottom of the centre fuselage, and then we're back at the undercarriage again. Another view of Concorde's wing going from tip to the wing root. Going to head inside Concorde now. We're going to go on board, see what we can see. Here's an excellent view just before we go inside of the fuselage, looking rearwards towards the tail. See that ogive shaped wing, all the fuel tank access panels, and then we'll look forward, access door there, there's the wing root. Right, let's go inside and have a look. We are looking down towards the rear of Concorde. Got some champagne there, look for us, Harry.
Yep.
They must have known we were coming, mustn't they?
Yeah.
Well, you can see immediately just how small it is. I mean, it's like a short hop airliner, really. And that was its downfall. They just couldn't get enough people to fly on it. There wasn't enough room for passengers. It was always going to be an expensive deal. And unfortunately, that just wasn't the way air travel was going. The way air travel was going was slower aircraft, perhaps, but longer distance routes, and many more passengers. It wasn't going to be a luxury. It was going to be, instead of a luxury flight at Mach 2, it was basically like getting on board a bus. And that was the way it went. He wants to say something to us, despite the fact that the aircraft wasn't ultimately as successful as was hoped.
It's still a marvel of engineering, and I really do like it.
It is a marvel of engineering. It's an absolute triumph. No one else could do this. Apart from us, yeah. So we'll head down now towards the flight deck. Really do get a sense of just how small it is in here. And up here we have some panels telling us Mach 2, 55,000 feet, minus 55 degrees Celsius outside, and we'd be cruising at 1,380 miles per hour, or Mach 2 if you prefer. Right, let's go and have a look at the flight deck, Harry. We can't, it's sealed off, yeah, but we can still see. Oh, lovely. They don't get any better, even in a supersonic aeroplane.
I'm looking inside the flight deck. I can really see how that droop snoot works.
We're going through the door that you wouldn't normally be able to go through. No admittance. Got some circuit breakers. Let's see how you fly a supersonic aircraft. Wow, look at that flight engineer's
You
panel.
can really see how the droop snoot would have gone down,
Yeah,
then gone up again.
you can. So there's all the flight engineer's controls.
Don't think I would be able to fly that because you can't
there's
really see much out
Pilot
there.
and co-pilot.
Can't really see much out
Yeah.
there.
So as Harry was saying, the droop snoot would have had to drop so that the pilots could get good visibility on the ground, which is the position it's in now. You can see those Bristol aeroplane goat's horn yokes there. Very, very distinctive. Bristol built this aircraft. It was built at Filton anyway, so Bristol Aeroplane Company, as it used to be, they put their stamp on it by giving it those ram's horn rather yokes. Just to let you know what Concorde we're looking at here, we're looking at Golf Bravo Oscar Alpha Alpha, or simply Alpha Alpha as it's usually referred to. And Harry's now got a little message for us.
This concludes our filming on Concorde.
So we were just looking at the clamshell thrust reverser at the back of the Bristol Siddeley or Rolls-Royce Olympus, and I said I'd show you one closer up. So here we are. This is what they look like. So this big hinge here, big gimbal, allows, it's a spherical bearing, you can feel the sphere shape there. This is actuated, I would believe, probably by compressed air, bleed air, and it closes up along with the other one and forces the turbine gases from the jet pipe to go forward, and that then slows the aircraft down. Thrust reverser, basically. So here you would have a Hawker Siddeley or British Aerospace as it became Hawk T1A, and this one is obviously from the Red Arrows aerobatic display team. And the reason this aircraft is in the same hangar with Concorde is because famously Concorde and the Red Arrows did a simultaneous display together. So here you would have a jet stream. This is just the fuselage, obviously. Originally designed and built by Handley Page, then taken over by Scottish Aviation at Prestwick, which eventually obviously became British Aerospace. And this one was built in 1969, I believe, but then it was taken over to the States, where it was flown over there for a few years in airline service. Then it came back to the UK and was converted into a super jet stream, or the fuselage was, and it was then used as a means for a sales pitch, or a prop for sales pitch, to show prospective customers what a super jet stream would look like inside. And over here we have got a small Mercury ground towing tractor, which is an absolute beaut. And if I worked here, I'd want to try and get this thing running. Can't see much of the engine because it's pretty dark in here, but there you go. Mercury Truck and Tractor Company Limited, Coventry, Gloucester, England. What a beaut. And just beside us there you can see the fuselage of the 707 that we've just been in looking at. So we're on board the Boeing 707, or at least part of the forward fuselage of a Boeing 707. And here we can see the flight engineers station, which is not massive, quite small, not as big as the one in a Nimrod actually. Then we've got the pilot and co-pilot seats, some CBs there, and just, you can't quite see it, just down in the bottom left hand corner there is the periscopic sextant, which they'd use for navigation if all else failed. And that would be put through, I think you can just about see it, can you? Oh, there it is, yep, there it is, through there and out to through the top of the fuselage. So looking along the length of the fuselage now, there we've got the ubiquitous toilet. They never look very nice, do they? And the galley area where the stewardess, there she is. Oh, she's headless, never mind, I'm sure she'll recover from that. She'll make you a cup of tea. And then we've got various displays inside this fuselage, and you can actually see the structure. A bit of music jumping in there. Structure of the aircraft there. And you can see a display that tells you all about the evolution of airlines and air travel in general. And there's Harry watching the film that explains about the Boeing 707. This is quite an interesting exhibit. It's a ram air turbine from Concorde. So the purpose of this device was, if power failed, if you lost engines and you were having a really bad day at the office, essentially, this ram here would deploy and it would put this ram air turbine into the airstream. And the airstream would drive this small propeller, which would drive up through bevels in there, through a drive shaft in the stem, up to the top. And then if I move around, you can see it would drive these two hydraulic pumps, which would then give hydraulic power to operate the flying controls, and then from hydraulic power through a power transfer unit with a hydraulic motor driving a generator, you could also get electrical power. But if that ever was used, that was indeed a bad day at work.
It would have been used to put out large fires on airports when a plane caught fire. Very useful if you had a fire to put out.
Yep, so as Harry says, we've got this Simon Meteor fire tender here, airport fire tender that was previously used at Edinburgh Airport until the early 2000s. So let's have a look at it. I think the 12-cylinder diesel engine is in the rear, and I think the firefighting equipment on this was built, some of it was built by Gloucester Saro. And there we go. British Airports Authority Airport Fire Service. So what we're looking at now is the flight deck of a Trident. They've got a Trident nose section here. Now, I apologise, it's a bit dark and difficult to see, but what you'll notice, if you look carefully down at the central pedestal, there's a lot on this aircraft in common with the Comet 4 and the Nimrod, the ultimate derivative of the Comet 4. A lot of the systems, mechanical systems and airframe systems were similar, or even just exactly the same. And you can see down there on the central pedestal, the two trim wheels are exactly the same, or more or less exactly the same as the ones in the Nimrod. And if I move around now to the flight engineer's panel, it is very reminiscent of the Comet 4 and the Nimrod. The gauges are exactly the same. If you look down there, you can see the pressurization controls are just exactly the same. The hydraulics gauges in the same place pretty much, and just about exactly the same. And the fuel gauges and all the switches for power are roughly in the same position. All the same kind of circuit breaker panels and fuse panels. So a lot of commonality between the Trident, the Comet 4 and the Nimrod. So here's another beauty, an AEC Matador 4-wheel drive 10-ton lorry. These were built from 1939 onwards for all branches of the armed forces. This one's in RAF colours. It says RAF Lucca on it. It was in Malta, and it was brought back from Malta in 1978, this particular vehicle. And it's had a winch on it at some point. You can see there, look, the guide rollers for the winch wire. So it had a 7.6 litre diesel engine in it, and its top speed was 30 miles an hour. And if you look at all the old footage of RAF airfields, you'll always see a vehicle looking like this. It was absolutely ubiquitous in the British Armed Forces during World War II. Now we'll head to the military aviation hangar. Off we go. So this is Supermarine Spitfire TE462. This is a Mark 15, and you can see it's got the clip wingtips. And as far as I understand it, this Mark had the Rolls-Royce Griffon engine. Here we have the ubiquitous, absolutely glorious Rolls-Royce Merlin engine. In cutaway, you can see the valves there and the pistons, or one of the pistons. Huge turbo supercharger at the back. And over here is an interesting contrast, because we have a Daimler-Benz engine from an ME109, which is an inverted V engine. So that was the German equivalent of the Merlin, essentially. Although this one is in a bit of a state. I think this one came from ME110 actually, and it was the one that Rudolf Hess crashed in when he tried to come to Britain in his misguided fashion. There's the turbo there. Provides quite an interesting contrast to the Merlin. So here we have a Bristol Bolingbroke, and this is the Canadian-built version of the Bristol Blenheim. And it's in yellow training colours, so the Commonwealth Training Air Training Service. This one was used to train air gunners. Another view of the Bristol Bolingbroke, or Blenheim if you prefer. I'm not sure what engine that is. I think it's probably a Bristol Siddeley Leonidas, something like that. So 2 of those anyway.
Fun fact, did you know that the Messerschmitt comet was flown by Captain Eric Winkelbrand when the British Air Force tested a captured version of the comet?
So here, as Harry has just said, is a Messerschmitt comet, German rocket-powered interceptor. And as Harry has alluded, it was flown by Captain Eric Winkelbrand, the famous British test pilot, the man with more aircraft in his logbook than any other pilot ever, basically. So these aircraft were built primarily by slave labour, and they were fueled by hydrogen peroxide and methyl alcohol in a rocket motor unit that we'll look at in a minute. So they were pretty lethal to fly. Hydrogen peroxide would melt you basically if it leaked out of its container, or its tank rather. So these things were designed for shooting down enemy bombers, and I think they made a total of 16 kills for a loss of 10 of these aircraft, so not a great statistic really. And the landing gear was a bit strange. You can see there this little bogie was detached or was jettisoned on takeoff, and then the aircraft landed on a skid, a spring-loaded skid that popped out, and then the little bogie landing gear was recovered, and then it was fitted back to the aircraft again when it was ready to fly again. And that little propeller on the nose is for driving a generator for powering the electrical systems in the aircraft. Here's the Walter rocket unit that powered the Comet. So the rocket thrust chamber is this little bit on the end here, and then attached by this long tube is all the pumping gear and control system. So this used hydrogen peroxide as the oxidizer and methanol and hydrazine hydrate mix as the fuel. So they'd be pumped along into this thrust chamber where they'd spontaneously ignite and give the rocket thrust to drive the aircraft forward. So yeah, these things, the thrust chamber, there's some welding on there that even I would be, that makes me look good, that does. But as I say, these things were built primarily by slave labour, so they might not have been well disposed to do a particularly good job. But having said that, for the time, it was an incredibly advanced unit. Rocket propulsion. To the rocket unit for the Messerschmitt Comet, the Walter rocket unit, we have this Ferranti labelled Gloucester Meteor, and this is an Armstrong Whitworth built Gloucester Meteor, and it was used by Ferranti for testing radar systems. And it's a strange old bird in many ways because it was built when jet engines were first being used in aircraft, so they didn't really know what to do or aerodynamically what the aircraft should look like. So we've got straight wings built like a piston aircraft really, and the engines are in pods on the wings. There we are. This long nose is because this aircraft was used for testing radar systems, which we'll look at very shortly, a Ferranti built radar system for the Lightning. So this aircraft was built in 1953. And in a minute we'll have a look at another early jet aircraft that uses a lot of the German research into aerodynamics that when these aircraft were designed, the Meteor, wasn't really known about, hence the straight wing on this particular aircraft. What we've got essentially here now is a MiG-15, or as it's labelled up here, an Aero S103, because it's a Czech-built, license-built in Czechoslovakia MiG-15. And you can see this aircraft was built in 1956, so it's of a similar vintage to that Meteor. But this was built, the MiG-15 rather, was built using captured German aerodynamic information, which led to the use of the swept wing, which is much better at high speed than the straight wing as we've seen on the Meteor. So this aircraft had a derivative of the Rolls-Royce Nene engine in it. The Rolls-Royce Nene engine was given to the Soviet Union in the late 40s, and they developed it into their own version. This aircraft, the MiG-15, famously shot down a United States Air Force fighter that strayed into Czechoslovakian territory in the early 60s, I believe. So here we have, this is a Motorlet M06, which is a Czech-built version of the Russian copy of the Rolls-Royce Nene engine. So there you can see the centrifugal compressor, just like in the jet engine that we're building. And there's the combustion chambers. We have the world-famous Hawker Siddeley Harrier, the Rolls-Royce Pegasus engine. This gave the Argentinians hell in the Falkland Islands in 1982. Shot down various Argentinian fighter aircraft. So this engine, compressor at the front, obviously axial compressor, and you can see the two nozzles, or four rather, two at each side. The front one from the bleed air from the compressor, and the rear one is from the turbine. And then those nozzles communicate with these nozzles on the aircraft, which can be vectored to provide vertical takeoff and thrust for normal flight. Absolute ubiquitous aircraft, British aircraft of the Cold War, the Lightning, English Electric Lightning. Mach 2 interceptor. Could go from ground to 33,000 feet in about 2 minutes. Limited range. See the bulge in the belly there? That's an extra fuel tank that was fitted to increase the range. Two Rolls-Royce Avon turbojets, one on top of the other inside that fuselage there. And here is the air interception radar built by Ferranti on its testing cradle. The Rolls-Royce Avon as fitted to this aircraft, the Lightning, or as it was called by the people that flew it, the Frightening, because its landing speed was like most aircraft's takeoff speed. So the Avon engine was also used in the Fairey Delta II, which interestingly was the first aircraft, British aircraft, the first aircraft in the world to fly at more than 1,000 miles per hour. British and European aircraft, the Tornado, used up until comparatively recently. Here's a Turbo Union RB199, Rolls-Royce RB199 engine used in the Tornado. Another view of the Tornado with its air-to-air refueling probe extended. And here's the Fox Hunter radar off the Tornado, again developed in Edinburgh by Ferranti's. And here we have a Seppercat Jaguar with a British aircraft. This is a Sea Venom. So this is a carrier-borne aircraft, Royal Navy aircraft, and it was used in the Suez Canal campaign to attack Egyptian targets. This particular one was built in 1955, so folding wings obviously because it was used on a carrier. I worked on an aircraft that had folding wings, the Buccaneer, when it was transferred into RAF service from the Navy. There's the mechanism for latching the wing when it folds in. Quite similar to the Buccaneer one actually, with that pin. And that's the indication mechanism there. That sort of little quadrant moves this perspex rod down. So you can, if you can't see that protruding, basically you know that the wing's properly latched in position, ready for the aircraft to fly. So here at the top we've got a Sparrow air-to-air missile as used on the Phantom, and at the bottom an SW-23 gun pod, again used on the Phantom. And here we've got a Seahawk, de Havilland, same as the Venom, Sea Venom, de Havilland. Show you a bit of a close-up of the folding wing mechanism on the Seahawk. So there's the hinge, and then there's a hydraulic ram there that's not connected to anything, but I believe that would have been used to move this bolt which slides in here to lock the mechanism or lock the wing in position. And then we've got some hydraulic walking joints here to transfer hydraulic pressure through the fold, through the folding joint, up into the wing, probably to operate powered flying controls for operating the aileron and the flaps. So I've just noticed in this corner of the conservation hangar a nice little Myford lathe. Can't really go without shooting a little bit of footage of the Myford lathe. There she is. So here we have the de Havilland Comet, Comet 4, which is just like the Nimrod that I used to work on. Almost exactly the same. There's the D door open, like we used to open them when we used to have to wash them. Well, I didn't have to wash them, someone did. My job was to open that door so they could wash the undercarriage. Speaking of the undercarriage, that is exactly the same as the Nimrod. Which it would be, of course, because it was exactly the same as the Comet 4 in many respects. Someone's not happy. The Nimrod had exactly the same 4A tank there as well. And the wingtip had the yellow gate on the Comet 4's flight deck. And you can see it's very, very similar to the Nimrods, if not almost identical. So here we have the Avro Vulcan. We're going to take a closer look at it in a minute. I've always thought that it's absolutely amazing that this aircraft came into service in the late 1940s. It was built by the same company that built the Lancaster. Can you believe it, that this thing was in service about 5 or 6 years after the Lancaster? What a quantum leap that must have been then. And let's go and have a closer look at it. So this is Vulcan XM597, and this one took part in the Black Buck operation over the Falkland Islands in 1982 when we handed the Argentinians their arses. So this one did 2 Black Buck missions, flying from Ascension Island and being refueled by a very complex chain of aircraft including Victors and Buccaneers. And this one destroyed 2 radar installations. And it then, on the second mission, had an issue with its in-flight refueling probe, so couldn't refuel and had to land in Rio in Brazil. Here's the in-flight refueling probe that was specially fitted to these aircraft for the Falklands. And then let's walk along the fuselage. There's a huge intake feeding the 2 Bristol Siddeley or Rolls-Royce Olympus engines, 2 on each side, and you can just about see from this angle the Delta wing, absolutely revolutionary at the time when it came out. Look at the acreage of that, just the huge wing area for lifting, you know, the payload of bombs. And this thing was designed to carry nuclear weapons. Notably the Blue Steel standoff missile was used. We'll go underneath now, we'll have a look. It's in a bit of a state, this. It's a bit of a poor old thing really. There's quite a lot of corrosion on it actually, as I've noticed as I've been looking round. There's the nose bay. I'll show you as much of that as I can. Nose leg. Turning back to the fuselage, you can see some of the corrosion. It's just horrendous, some of it. There's the bomb bay. And this aircraft had a really interesting flying control system. Each separate flying control unit had an electric driven pump on it, so there was no dependence on hydraulic pumps driven from the engines. There's the main gear, one side, looking up into the wheel well. Walking back now towards the jet pipes. Plenty of corrosion on this. That's just horrendous. Needs to be brought inside, and all this needs to be sorted, but I don't think it's ever going to happen. And there's the relic from 1982. 2 Argentinian tallies there with 2 bombs showing that 2 targets were destroyed. And there's the Brazilian flag showing that this aircraft landed in Rio because of the in-flight refueling probe fault that I told you about earlier on. We really need to have a look at this. This is a Napier Nomad compound turbo diesel engine. And when I say turbo diesel, I'm not talking about a turbocharger and a diesel engine. I'm talking about a gas turbine compounded to a diesel engine. So the exhaust from the diesel engine is used in the turbine. And I would encourage you to read about this thing elsewhere because it is an amazing feat of engineering. It weighed 1.5 tons. The exhaust from the diesel half of the engine is recycled to boost the turbine half of the engine, which delivered incredible fuel consumption. What an amazing thing. What a beautiful piece of engineering that is. Here's the exhaust running down, look, from the diesel engine into the turbine. And then standard axial compressor at the front. Have an Avro Anson. A lot of these aircraft were used in the RAF, transport, training, and then after the war they were often used for aerial photography. And this one has a particularly interesting oil cooler or radiator of some description. Someone will tell me. It's an interesting design, isn't it? And here's a twin Pioneer, again, another aircraft that was used quite extensively for aerial photography. So here we've got a de Havilland Dove. This one was built in 1954 and was one of the Brabazon Committee aircraft, or aircraft that was designed as a result of the findings of the Brabazon Committee. And I think this one was primarily based at Stansted. We have a Beech E18S piston-engined airliner, twin piston engines, and Harry has some fun facts for us.
Fun fact, did you know that this plane here flew from Glasgow to Norway and it was used to carry newspapers?
I didn't know that, but now I do. You're the twin Pioneer. So this is a fuselage section of a Spartan cruiser. This was a 1930s passenger aircraft that carried airmail. And this one crashed on the way to Campbelltown whilst carrying reels of film for a local cinema. And it was recovered by the museum from its crash site on the side of a hill. So this is a de Havilland Dragon, and it was built in 1942. These were used a lot for the inter-island service up in Scotland, sort of pre-war and just after the war. And this has got Gypsy Major engine, just like a Chipmunk. And here we've got a Jetstream, like we were talking about before in the Concorde hangar. This is a full one, not just a fuselage. This one was built in 1969, and I think it was upgraded to be a Jetstream 3 in 1980. Yeah, it was. Just reading the panel about it. Up above us there we have a Grasshopper glider. What a beauty that is. And this is a Miles M18. So these were kind of 1930s. I think this was built in 1939, this particular example. Another Gypsy Major engine in that. They were originally considered to be trainers for the Royal Air Force, but they were no orders were ever placed for them. But this particular aircraft was flown by Brian Isles. He bought it in 1948 and he flew it in lots of air races. This aircraft here is a Cygnet, and you can see it's got the Royal Air Force roundel on it, used by the Royal Air Force. And in 1942 this aircraft was flown twice by none other than Wing Commander Guy Gibson, the leader of the Dambusters 617 Squadron. So this little beauty is a Druin Turbulent, and it was designed as a home-built aircraft. And this particular one was built by a man called John Sharp in his house in the town of Airdrie. And the wing was constructed across a hallway into 2 bedrooms. And then the family had to crawl under the wing on a night time to get to bed. Final assembly of the aircraft, it said, was completed in the school playground in 1974. So this thing is driven by what is a Volkswagen Beetle engine. There it is. And yeah, that's a bit better welding than it was on the Balta rocket engine. Yeah, I didn't do that. So there you go. A VW Beetle engine in an aeroplane, which is not that unusual actually, because if we go over here, I will show you this Lycoming engine, which was essentially derived from the same thing. Here is a Carmichael Stonefield 6x4, really miniature airport fire tender. It's a lovely little thing, and this was used at Barra Airport, I believe, on the beach airport there, where the aircraft used to land on the beach. And then behind us we've got a Britain Norman Islander, which used to do the island service. This is actually an air ambulance, this particular one. It's got the ambulance crest on it there. And this aircraft has got the Lycoming engine like the one I just showed you in it. So we're back at the 111, BAC 111. So we enter through the rear of the aircraft.
It's nice and clear.
It is, isn't it? Typical aeroplane smell, which we know and love.
Welcome aboard the BAC 111.
So that's where we came in from. So that must have been noisy when people were getting on board, because the APU is just above where those steps are.
That's the exit, Dad.
Yeah,
But I think they just want us to come in that way.
I think you're right.
Maybe to give us a better view.
So a bit like the Comet, a row of 3 and a row of 2. Let's head up towards the flight deck then, Harry.
Okay.
Some good photographs there. British United Airways.
Yeah. Now, even though I usually do the fun facts,
Yeah.
there's some fun facts boards up here.
There are, yeah. And this was designed to replace the Vickers Viscount, would you believe, Harry?
Wow.
The 111. Bit like the Trident, I suppose,
Yeah.
in some ways. Similar systems, probably, I would think.
Quite nice.
I wouldn't be surprised if we find that the flight deck is similar. Well, actually not. Well, very similar yokes to the Nimrod. Not too dissimilar to the Comet and to the Trident either, actually. With those aileron and rudder trim wheels there, where in that position on the left-hand side of the throttles there, and a lot of similar looking gauges, and the panel there above the pilot stations.
We hope you've enjoyed the video, so we decided to have a super special conclusion, so we brought you back to Concord. Hi again, we're back inside Concord for our conclusion. We hope you've enjoyed coming around East Fortune Air Museum Edinburgh with us. Please like and subscribe to the channel, and thank you for coming with us.